The broadcast is now starting. All attendees are in listen-only mode.
Good morning all the participants who have joined us from the United States, and very good evening to everyone else. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is performance testing in cloud right before your eyes. In our panel today, we have two guest speakers. Our first speaker is Mr. Sairam. He is AVP Marketing for Gallup Solution, and today he will brief us about the Gallup solution and its functioning. Our lead speaker today is Mr. Kranti Pedi. He is performance architect at Gallup. He will take us through the presentation. So without any further delay, I introduce you all to our guest speakers. Over to you, Sairam.
Yeah. Hey, thanks. Welcome everyone for today's the Start Leadership webinar on the performance testing. A little bit about Gallup. Myself, Sairam. Gallup Solutions is a 10-year-old US-based co-located independent software testing services company. We specialize in doing co-located software testing on the agile paradigms, serving leading enterprises and independent software vendors. We also do very specialized QA staffing services, and we are headquartered in Philadelphia with offices in Dallas. We have backed one of the cornerstones of Gallup's offerings is our enterprise test acceleration suite, our own testing IP for rewarding enhanced productivity and in-house R&D teams that complements this effort. We are actually a 100% subsidiary of Signity Technologies, the world's third largest independent testing services company. Over the last decade, leading organizations across the verticals have relied on Gallup's competencies and Gallup's software testing leadership in terms of realizing optimal return on investments on their software quality initiatives. Gallup constantly innovates in the R&D around software testing, and one of its major items of focus is to contribute immensely to the testing community by thought leadership blogs, white papers, and webinars. As part of this initiative, this is the second recent webinar that we are bringing up. The one for today's agenda is performance testing in the cloud right before your eyes. The one that's going to present today is Mr. Kranti. Kranti is the performance architect at Gallup Solutions. With more than 9 years of industry experience across software development, quality assurance, and performance engineering, Kranti constantly works to provide discipline and guidance to our performance testing teams at Gallup. He brings across his experiences on various best practices of performance engineering, helps troubleshoot complex bottlenecks with deep down analysis on .NET, Java, and mobile platforms. Kranti also spearheads a whole lot of activities in working towards setting up distributed performance testing centers of excellence, and particularly specializes in solving very complex engineering problems. He obviously believes in Steve Jobs' words, and what he thinks is the only way to do great work is to love what you do. Without delaying further, let me also hand this over to Kranti, who spends the rest of his time obviously doing a whole lot of travel, and here he is today bringing in all his experiences about performance engineering. I hope this will be an insightful session, and let's get going. Over to you, Kranti.
All right, thanks, Sarah. Hey guys, good morning everyone back in US. Good evening everyone, someone joining from India. Without any further delay, let me go to the agenda of today's program. This is what it looks like. We are going to see what exactly cloud means and what are the different service offerings that cloud offers us, and go on to the performance testing in cloud. What are the drivers and what are the challenges that come across when you try to take up your performance testing to cloud. And then we'll go and see what type of applications fit for cloud-based performance testing. There are a whole lot of type of applications. You have a mobile application, mainframes, etc. We'll see what type of applications fit and what type of applications do not fit for cloud-based performance testing. And then we'll see how a general cloud-based performance lab architecture looks like. What are the different ports that you need to take care of when you're monitoring or firewall. What are the different challenges that you will have when you're communicating with, when your controller is communicating with your application under test. And we'll see what are the cloud performance testing providers as a SaaS, PaaS, etc., and their pricing models. Then we'll jump on to see when do you actually build your own performance lab and why do you want to build your own performance lab. We'll ask certain questions, and if any of these particular questions has an answer as yes, then probably you might want to look at building your own performance lab in cloud. And finally, we'll see a demo using Amazon AWS Cloud. And before going to the demo, we'll see what Amazon AWS offers in types of instances and available options, what are elastic IPs, what is a virtual private cloud, etc. So what exactly is cloud? You hear a lot of buzzword around this cloud usage, and everybody says cloud. Let's see what exactly cloud stands for. From Wikipedia, it says that it's a network-based computing in which large groups of remote servers are networked to allow centralized data storage, online access to computer services or resources. Basically, what it says is you don't really have to care about how many CPUs are there, what is the memory that you have, what is the disk that you want. You can just slice and dice according to your usage, and all the virtual machines that you're offered to on your cloud can be controlled through programmatic API. Another explanation from IBM says cloud computing, which is often referred to as simply the cloud, is an on-demand service which is available for pay-for-use basis, which actually is the secret behind cloud. The reason why cloud has become so big and why everyone wants to go onto the cloud is, number one is the cost, number two is obviously removing the headache of maintaining your own infrastructure and your own data centers. Let's see what type of services that are available in cloud and what interests us and what can aid us in terms of taking a performance test lab into the cloud. The first type of service that it offers is infrastructure as a service, which tells you basically that they are going to give you any type of servers, networking. It includes CPU, it includes memory, it includes your disk I/O, it includes your networking, everything from infrastructure perspective, which you can pay as per your usage. And then comes your platform as a service, which, if I have to take an example, Force.com, which is a Salesforce.com cloud, is a platform as a service. They provide you all solutions that are needed to develop products using their own platforms, and you go ahead and deploy them in the cloud itself. Microsoft Azure is one more good example when it comes to platform as a service. And then you have software as a service, where software runs on their own computers and managed by the SaaS provider. You don't really have to worry about what goes into the deployment, what goes into the challenges, etc., etc. You just need to pay them on a subscription basis on a monthly or yearly, and you get the service. The best example is New Relic, which is actually an application performance monitoring service, which is given as a software as a service model in the cloud. So now that we have seen what exactly is cloud, what it offers to us in terms of infrastructure, what it offers to us in terms of software service, platforms, etc. Let's see why should we actually take a performance testing into cloud. And most of the time we have in-house development teams, we have our own infrastructure, we have desktops and servers readily available for performance testing. Why should I actually take performance testing into the cloud? If we start looking at the drivers that take us to the cloud, the first thing is high on-premise costs. Needless to say, you can run all your performance tests with 500 virtual users, 1,000 virtual users, 1,500 virtual users on your desktop machines, have 3 or 4 desktop machines spin up and then complete a test, give the desktops back to the testers, developers, whoever it is, or you can use your own desktops in the night time and have a build run for performance testing. But when you talk about large-scale tests, let's say you want to actually mimic what exactly happens to your application when there is a surge of 50,000 users hitting your servers. Now, looking at the type of applications that you are testing, let's say if it is a very rich UI application and you have developed scripts using a commercial tool like LoadRunner, and obviously according to your script weightage, your basic desktop machine, most of the times it's configured as 4 gigabytes in memory. It might scale up to only 50 users. So imagine using 1,000 desktop machines all across this particular your office space, if you have 1,000 machines at all, for this particular testing, and you're still not sure whether your CPU holds it up, whether your memory holds it up, etc., etc. And you don't want to actually invest in so much of hardware. You don't want to bring blade servers into place and then use them as hi-fi load generators with 16 gigabytes of RAM, 32 CPUs, etc., etc. And then the overhead of maintaining your own performance lab comes in when you have actually dropped in the servers, because performance testing is most of the time, it's not a continuous activity, it's a periodic activity that you want to do until unless you have a regular, a very mission critical performance testing job which is running every night. It's most often you see your performance test running in once in a week or twice in a week, and once you're done with those tests, the maintenance of this particular infrastructure becomes an overhead for you. The second thing and most important thing is the real user experience. What exactly happens when you test your application inside your firewalls, inside your office spaces? You don't really get to see what is the effect of latency in on your application. And if your application uses a lot of JavaScript, and the modern browsers, whenever it encounters a JavaScript, it blocks the remaining resources from getting downloaded. Only when the JavaScript comes in, it compiles, it executes, and the browser understands what the JavaScript is about. Only then it opens up the remaining 5 connections to download any other images. And the moment it hits another JavaScript, the same old thing happens. And you can see this if you actually go and open your Chrome developer tools and see your network timeline. You'll see a waterfall model wherein, depending on your internet speed, it can take up, a 3-second request can take up to 8 seconds and 10 seconds. And in addition to the way your page elements are laid out, there comes this latency and hops. For example, a person who is sitting in Singapore trying to access an application which is hosted out of California data center will have to go through 14 hops or 15 hops. Whereas that's not the case for a guy who is sitting nearby, let's say who is sitting in San Francisco and trying to access this particular application. The latency might be only 30 milliseconds for him, but for this guy, the latency and hops are much more higher. And you want to take that into account when you actually performance test your application in terms of what your real user experience is. For example, you have a e-commerce site opening up, and you want a similar experience across all geographies. You don't want users from Singapore, or you don't want users from Australia getting frustrated because the page doesn't load up. Excuse me, because of all the hops that it takes. Generally what you do is you just measure this particular latency and then take a decision on whether you want to go for a CDN distribution of this particular applications, etc., etc. And then comes your high concurrency testing, which is again plays a part both in the cost and the real user experience. For example, recently, 6 months ago, we have tested climate solutions providers device which talks to a SQL server on Microsoft Azure platform. And the moment there is a power outage, or the moment there is a sudden change in weather, they expect around 50,000 service calls coming in a span of 5 to 10 seconds onto their servers. Now, that scale of testing is really not advisable to be done on your office networks. It's always better you take it up to the cloud, and with all the bandwidth that is available, with all the servers space and memory and RAM that is available, it's pretty easy, and you don't really end up paying a lot of money to those particular guys, depending on the options that you choose, which we'll see as a part of our Amazon EC2 demo. You might end up paying only $30 or $40 or $300 or $400, depending upon your usage. And then on-demand provisioning, no dependence on infrastructure teams. So 2 more reasons, which we have pretty much covered in high-premise cost and real user experience. So having discussed those particular drivers, let's see, okay, now we understand that, okay, whenever there is a cost restriction, or whenever there is a high concurrency testing that I need to do, or whenever I need to get a real user experience of what my response times are from different geographies, then comes the question, okay, what sort of applications do I take to cloud? Because there are a lot of types of applications. You have a thick client-server application sitting on your application landscape. You have your own internet applications, which you might use for your own communication, organizational wide announcements, etc. And then you have desktop-based solutions. You have mainframes, and you have web and rich UI. And in this case, if you see the client-server applications, most of the time they are deployed on a corporate LAN, or they don't actually work out of a firewall. You can actually divide these particular 6 categories into behind the firewall and outside the firewall. If your applications are public facing and if your applications are being accessible or being accessed through various geographies, that's where your web and rich UI fall in, are the actual candidates that you need to take into your cloud application, cloud performance testing. The reason why you do not take internet applications into cloud-based performance testing is, the reason is pretty simple. You end up using your internet applications inside your corporate LAN. You don't actually hit this particular application, or you don't generate the traffic from outside the firewall and then see what exactly happens to your internet. And it also involves opening up a lot of firewall rules, talking to your security teams, and the sort of cost that you put in actually testing these applications on cloud for no reason is not a good fit for taking these to the cloud. Whereas if you have a web application or a rich UI application which is public facing and which is being accessed from different locations at the same time, and you have different sort of latencies coming into your servers, those two are the right candidates that you want to take to the cloud and then start testing. So now we have seen what are the drivers and what are the types of applications that you actually want to take to cloud to conduct a performance test on. Now let's see what are the challenges that you actually typically see when you start performance testing in cloud. Number one is actually the repeatability in results. By repeatability in results, what I say is, when you go to cloud and spin a machine as a load generator, any cloud machine that you get is a virtual machine. It's not a physical machine. And the way the spin is using a programmatic API. And if you spin the same sort of configuration twice, you're really not sure whether you're going to get the same amount of CPU, same amount of RAM. Though from virtual machine per se, yes, but you really don't know how much load the actual physical machine is under. So the performance of your virtual machine under different runs will be slightly different. And if your response times are really critical for you, it depends on the level of tolerance that you have in terms of response times that you put in there. Let's say your response time scales are 3 to 4 seconds. You're really good with anything between 3 to 4 seconds. And in this case, you really don't see much difference because most of the time the differences are around 0.5 to 0.6 seconds. But what if you're a trading platform, or what if you're a mission critical application where even 0.5 to 0.6 seconds of delay might cause problem for you? And you can't rely on the numbers between two different VMs and two different tests, giving you different set of numbers which you can't rely with. So that's one thing that you want to take care of. Most of the time what you want to do is repeat these tests. Repeat as many number of times as you want, and then take out the outliers. Take the average. Don't take the average. Take the 95th percentile. Take the 97th percentile. Take the 98th percentile, and calculate the mean deviation between these runs and arrive at an educated guess. Though it provides an advantage in terms of high concurrency runs and cost savings, as a best practice in your performance testing, you just cannot rely on one performance run that is done on cloud, because you can't actually go ahead and take those numbers with confidence if your response time SLAs are really critical. But if you are okay with a tolerance of 0.5 to 1 seconds, that doesn't actually make a big difference to you when it comes to analysis. Second is the permanence of hardware. So as I said, you don't really get the same virtual machine in the same health every time you spin a load generator or every time you spin a virtual machine on the cloud. And most of the time what happens is you share a network interface card with a lot of other systems over there, and your network bandwidth is also not really constant over your testing intervals or over the days. In order to solve this particular problem, most of the cloud providers, what they do is they offer you something called virtual private cloud, wherein in this virtual private cloud you have your own network settings, you have your own network interface cards, you can create your own firewall rules, and the machines that you spin out of your VPC will share this particular same network and same hardware without any change, and thus giving you a sort of stability in terms of your virtual machines, a sort of stability in terms of your test results. The third one is the firewall restrictions. It depends on the type of performance lab architecture that you have here. If you are taking your controller onto the cloud, it's pretty much easy. Your load generators can communicate with your cloud, with the same load generators in the cloud, and your controller doesn't have to really bother about opening up firewalls to communicate with this particular load generator. But that particular situation will lead you to another problem. The controller, if it wants to communicate with your monitoring software, let's say you have an HP Diagnostics or you have an App Dynamics, which obviously are installed on your application servers, which will be probably in your DMZ zone or which will be behind your firewall. You really can't do that by having your controller sitting in the cloud and application servers sitting inside your firewall and make them communicate. And you will have to open up a firewall port for these particular things to communicate. Similarly, your load generators will have a restriction on communicating with your application under test behind a firewall. Basically, you will have to open up a lot of firewall ports there. And trust me, a lot of times, though it is pretty easy on the face of it, your security teams will never allow you to do it. For some reason, they'll have 100 reasons to tell you you cannot open a firewall port, and you'll have to deal with all these particular policies and rules and regulations. The last one is data privacy. If you're really testing a financial application or a regulations applications where you're really worried about the data that is going on this particular unsecured network, because once you go and generate a load out of cloud without actually opting for a virtual private cloud, and you go and spin machines on elastic compute, it's a multi-tenant system. It's going to share what you call it as a single network interface card will be virtualized and shared between your different clients, and any data that is traveling on this is exposed to outsiders because your network is not safe, and your data is at risk. If you have sensitive data flowing through your transactions, it's always at risk. The same solution for this particular data privacy is to go for a virtual private network and have your network separated from the other networks. So here what we are seeing is a cloud-based performance lab architecture where different load generators are situated in different parts of geography, and the way they are communicating is the scenario that we are showing here is I have my controller inside a firewall, and I have all my applications inside a firewall, and my load generators are going to communicate to this particular application under test, as well as my load generators are going to send the transactional data and everything to my controller. And there are several settings that you need to open up at the firewall. You will need to open up the SSH and RDP for load generator communication with the application under test through your firewall, as well as you'll need to open up port number 54345. This is for load runner in particular, and you need to open this particular port only for your IP range. This is very critical because once if you do not open this for your IP range, and if you just allow any IP into your firewall, you're compromising your settings. And then there is this monitoring piece that's going on between the controller and app server, and app servers and database servers communicating with each other. Once you take this controller out of this particular firewall and put it on the cloud, the monitoring piece, in order to do the monitoring, you'll need to open up another port through your firewall. And once you do that, you're actually putting your application servers, you're actually exposing your application servers. The two ports that are open there, the load generators are communicating with your AET, and the controllers are communicating with the load generators with 54345 port number. But the moment you take controller out of this particular firewall and take to the cloud, you'll need to meet the challenges of getting the monitoring done between your app server, monitoring data exchange between your app servers or the monitoring agents and the controller. Now till now what we have seen is what is a cloud, what are the drivers for cloud-based performance testing, what are the challenges, how does a typical performance test lab look like on cloud, and what are the ports that you need to open up when you actually execute a performance test on cloud. Now, are there any service providers that actually provide this sort of performance testing in the cloud, pay only as you go? Let's say you don't want to buy any tools, you don't want to buy any infrastructure, you just go there and tell them, okay, I have a requirement, I need to test my applications for 10,000 users for 3 times, and I need to run the test for 4 hours. There are several players who offer you same service in different models. Their pricing models are different, their operating models are different, the tools are different, and technologies are different. We are showing a representative clients here. These are the clients that we have worked with in the past. LoadStorm, Neotest, Sovasta, StormRunner. Load is one offering from HP, which is pretty new to the market, and BlazeMeter, which is based on JMeter and Amazon Cloud, and SprintBlades. Most of the times, the operating model for this is pay-per-use service, but slightly different in the way the package is priced. When we say the package is priced, all of them or each one of them has different pricing models. For example, some players play it on the credits. You need to buy certain credits, the minimum credits that you need to buy, and the moment you start testing, you'll start expiring your credits. And once your credits are gone, you'll need to go and buy more credits from this guy. And then there are subscription based. You can buy subscription per month, you can buy subscription per week, you can buy subscription for half year, or quarterly, or yearly. And it also comes with certain restrictions. So for example, in a BlazeMeter, you can buy a monthly subscription, and it tells you you can have 20 runs, and for a user load of 5,000 users, and each test not going beyond 3 hours. So that's the restriction they put on your operating model. And then the virtual user hours, days, what StormRunner Load gives you, you can buy the number of virtual user days that you want to. Let's say you have a test requirement for 1,000 users, and you need to test this particular application for 2 hours and 1,000 users and 5 tests. So that makes 5,000 into 2, 10,000 virtual user hours. So once you buy this 10,000 virtual users and you run this particular test, remember, once you start a test, whether you actually complete an hour or not, you are going to expire that particular virtual user hour. It doesn't actually care whether you run for 1 hour, whether you run for 5 minutes. Once you start a virtual user and you wanted to stop this particular test in 10 minutes for some reason, your 1,000 virtual users are gone. Similarly, in subscriptions and credits, it doesn't actually stop you, or it doesn't actually let you control on your usage. Your 15 minutes test or 1 hour test or 2 hours test is counted as a test. So as a downside, what you actually get is, when you're paying for 2,000 virtual user hours or 3,000 virtual user hours, you don't get a permanent license with X number of virtual users. What you're doing is you are not paying an entire license fee there. For example, if you need to buy a load runner controller with 1,000 users, you might want to shell some 60K or 70K to get that license. But here what you're doing is you're just paying some 2,500K or 2.5K or 2K to get 5,000 virtual users, and then for a certain number of runs, you're using their infrastructure, you're using their licenses, and you're done there. So as a result, you don't get any permanent license, and you can't play around with these particular users. You don't have the luxury of having your number of smoke tests and dry runs that you get with a normal tool license. But nevertheless, they have their own advantages. If you have a very well-planned load test and you're sure you're not going to use more than 10,000 virtual users, or you're not going to use more than 20 tests in a month, seriously, these particular cloud service providers score more than having your own performance test licenses or tool licenses. So let's look at a comparative analysis of what it looks like when it comes to licensing costs. It combines both OPEX and CAPEX, your operational expenditure and capital expenditure. Example 1 deals with 1,000 users test, which runs for 2 hours, and there is only one run. If you need to provision this particular run, you'll need to get your hardware, you'll need to get your tool licenses in place, you'll need to get your network and everything in place. And if you look at the on-premise cost, it goes up to $2,300. Whereas if you actually compare that with a cloud service provider, it's pretty less. And Gallup has its own solution, Gallup Cloud Solution. We have actually overcome certain limitations with distributed testing with JMeter. What happens with JMeter when you actually test in different subnets is it won't allow you to have one master and different slaves in different subnets. Once you have different subnets, you will have to have different masters, and the results collation becomes really difficult. But Gallup has its own solution where you really don't worry about different subnets, different locations. Our own solution will go there and get the results and give you informative analysis on what's going wrong and what's going right. And the cost that you pay for Gallup Cloud Solutions in this case is far lesser than a cloud service provider. Let's go to the next example. Now this example deals with a high concurrency test, 30,000 users, and one run, which runs for 2 hours. And in order to actually get this done, if we calculate all this particular OpEx and CapEx in terms of hardware that you want to buy, in terms of licenses that you want to buy, you'll end up paying 46K if you want to get this done, the test done on premises. Whereas with a cloud service provider, it costs you around $1,500. And you come to a Gallup Cloud solution based on Windows or Linux, you will have different solutions. What we are telling here is we are telling about a JMeter based test run. Gallup also has its own partnership with commercial test tool providers. The pricings are different. We are not showing it here. We are purely talking about a web-based testing here. And the last example is a very typical example which runs in a large enterprise company. You don't have just one application, you have 50 to 60 applications, and most of the time your concurrent user load is 500 to 600 users. Most of your tests run for 2 hours, and if you want to count all these particular tests in a year, let's say you have 100 applications and each application goes through 30 runs in a year, and you'll end up with 3,000 runs. This is certain candidate for having your own performance lab either on cloud or having your own performance lab situated on premises for you. Because if you look into the cost that is there per run, that pretty much comes down on premises when compared to your cloud service providers or even Gallup Cloud Solutions. So now we have seen this particular cost analysis and the way the performance test lab looks like and the different service providers. So you have a lot of options now. You have a cloud, you have your own tool licenses with you, or you don't have tool license with you. You have an option to go to cloud and have a JMeter run, or you can go to a service provider that we discussed with, have different pricing options, and then you buy credits or virtual user days, or you pay a subscription and get the tests run. And then there is another question, the last slide that we have discussed, where you want to have your own on-premises lab or a lab that you want to control, you want to take it to the cloud. Now, when should you take your performance lab to the cloud, and why should you take your performance lab to the cloud? If we look, the first question is your number of test runs and the load you want to simulate, because these two particular factors will determine the cost that you need to pay on a long-term basis, on a long run. What exactly is the cost per test that you are paying? And the second question is, do you need absolute control on the number of load generators you want to use and the health of the load generators? Remember one thing, on a cloud, though you have control on the health of this particular load generators, it works differently. Let me take a step back here. You're operating your own cloud and you have visibility to your instances. But when you outsource your testing, or when you actually go to a service provider like a BlazeMeter or a NeoTest or a HP load runner cloud or a Storm runner cloud, you don't get to see, you are logged from what exactly the load generator is doing. You don't really have a control on what is the health of the load generators that are running there. And load generators being actually virtual machines, they'll have an extra task of catching up with your physical machine. Each and every interval, it has to sync with your physical machine time, physical machine CPU clocks. If it doesn't, it falls out of sync with your physical machine. So all this extra work that the virtual machine does and all the load that you actually push onto a load generator might get the CPU throttle, or might make the memory, the load generator searches for memory, or it runs out of memory. When it happens, what happens is the numbers that are reported by your load generators, which is not healthy, skews your entire performance results. In fact, if your response time is only 3 seconds, and if your load generator is actually facing problem, and it calculates for some reason your response time is 4 seconds, your entire numbers skew up, and then it shows on a higher side, which is actually not the case. So if you want have an absolute control on the number of load generators you want to use and the health of the load generators, consider your own cloud performance lab. And then if you want to use a mix of cloud and internal LAN users for all your tests, if your traffic is a mix, you have an application sitting on your data center, but your traffic is a mix of regular users plus office users, and you want to see the performance of this particular application across all this particular location, you have your own cloud-based lab. Or are you an independent software vendor? If you're an ISV and you want to take your own solutions to the cloud, or if you want to offer a performance testing on the cloud, building your own lab on the cloud is an option. Are you worried about your data security? Most of the times, if you don't have a virtual private cloud, as I said earlier, your data is at risk. And if you're really serious about your data security, you need to build your own virtual private cloud, and if you're actually going to the cloud. And if you're worried about the permanence of hardware, and if your load test schedules are random with little lead time. When we say this, what happens is you buy a subscription, or you buy a virtual user hour, or you buy a credit. No matter how long your test run, you're going to consume those particular credits, and you're going to consume those particular subscriptions or virtual user hours. If your load tests are not really planned, and if you can't really have a test run for 2 hours or 3 hours at a stretch, and if it's very sporadic, you have a window of 1 hour here, and you have a window of 1 hour there, and you really are not sure when your window opens up, going to a third-party cloud service provider is not an option. In fact, you might want to build your own cloud and manage it for yourself. It keeps your operation expenditure low, as well as it keeps your flexibility high. And if you have a licensed tool which you want to take to cloud, then better build your own performance cloud lab, depending on the competency of the test, depending on the load model that you use, depending on how many tests that you run. And if you don't have enough infrastructure back in your office, you want to use high-end infrastructure, you want to go to your you want to go to a cloud and have your own performance lab there. There is another factor here. Most of the times what happens is, on an evening or a morning, you go and actually kick off a performance test run within your infrastructure, and this particular test run will consume all the bandwidth that is there. And your internal office users and people who are actually using this particular network bandwidth will start facing your performance problems, and you don't want to do that. That's the reason most of the companies, what they do is they schedule this particular load test late in the day in order not to actually use the entire bandwidth that is available during office hours. So if your answer is yes to most of these questions, you need to just go ahead and build your own performance lab on cloud, or the second option is go to a cloud service provider and take their help in getting it done. Now, before going to see a demo using an Amazon EC2 cloud, let's see what actually Amazon EC2 has to offer to us. Amazon AWS is actually a web service that provides resizable compute capacity in the cloud. If you map it back to the first slide that we came from, the Wikipedia definitions and IBM definitions, you have a huge hardware and you want to use it slice and dice, and you want to do it dynamically. You have a virtualization in place, and then you really don't worry about what's in the back end. You just say, I need 2 CPU, 4 GB RAM, give me, and it gives you. And these particular Amazon Web Services API are available to build your own solutions. You can just go to Amazon and talk to them, and you can have your own cloud inside Amazon data center, inside Amazon EC2 or VPC, and use these Amazon Web Services and build your own API solutions for it. And inside your Amazon EC2, there are a lot of types of instances that they offer. The number one is on-demand instance. There's no long-term commitment that you are bound to here. You just go and say, I need a particular configuration, please give me, and you pay what you use for, pay by hour, and you go to aws.amazon.com, you can see what are the pricing options available there. And then comes the reserved instances, where I'm talking about having a permanence of hardware, but this comes at a cost. You pay a minimum amount upfront to get this particular instance reserved for you. But what it actually also does is, the hourly usage of your reserved instance is the price that you pay for an hourly usage of a reserved instance is pretty less when you compare to an on-demand instance. When an on-demand instance charges you around 0.9 or 0.8 or 80 cents or 90 cents, a reserved instance will only charge you around 12 cents or 15 cents or 18 cents depending on the configuration. But for that you need to pay a certain amount upfront, and it depends. I don't talk on behalf of Amazon here, so it depends on client to client, the way of the relationship that you have with Amazon. So the prices can vary. If you're a gold customer of Amazon, you can get it for a very good price. If you're new to Amazon, you get it at a different price. So there are a lot of pricing mechanisms behind it. And then there is a third type called spot instance. What it does is you can set a limit on your price, and as long as this particular bid price doesn't exceed this, you can keep using this instance. So what exactly you are telling them is you are setting a price limit that you won't go beyond, and the API will take control. Okay, because the spot instances prices vary between day to day and month to month and week to week depending on the demand and supply that they have. A spot instance which is 12 cents in a week can go up to 22 cents in another week. And if your bid price is set at 16 cents, it stops using this particular instance and saves you from higher usage. So this is a very flexible option, but it depends on what is your requirement in terms of scalability, what is your requirement in terms of throughput, etc. If you really don't have serious throughput and performance requirements, you can go ahead and use your spot instances. What it also does is it provides you with instances in multiple locations. You have a US East region, you have US West, you have instances available in California, you have instances available in Oregon, North Virginia. You also have instances available in Europe, Asia Pacific, China, and in between each location there are multiple zones. They have done this in order to isolate or insulate from single point of failures. If something happens, if something goes wrong in one zone, you still have another zone to fall back on, and all this particular falling back options and fail-safe options are exposed through your Amazon Web Services APIs, which you can take advantage of. And then there is an elastic IP address, which actually is stitched to your account and not to a particular instance. What it does is, let's say you have a solution which is load balanced across US East, US West, and for some reason West instance goes down, and you don't want to do the DNS mappings and keep your users from reaching this particular application. You want all this particular thing to be done on fly. You can go and reserve an elastic IP, map it in the account level, and manage this particular fail-safe operations via programs. There is a downside to this elastic IP. If you don't use it, you will have to pay for it. As long as you are using it, that's okay. But if you don't use it, there is a minimal amount that you need to pay per hour for every elastic IP address that you actually block. And then you have an Amazon Virtual Private Cloud. You can have your own network, virtual network. You are given your own network interface card, and you can set your own security principles. You can set your own firewall rules, inbound rules, outbound rules, etc. Lastly, you have an Amazon CloudWatch. These are only representative sections that are of interest to us. There are a lot of other services that Amazon offers. For a complete list, you can go and visit aws.amazon.com/ec2. Amazon CloudWatch is a service that monitors health of your instances. This is in particular really useful for performance testers, where you will be using multiple load generators and you are really worried about the health of the load generators. You don't choke the load generators for memory, you don't choke the load generators for CPU, and you want to keep a tab on what's happening on your load generators. You can subscribe for Amazon CloudWatch, which actually gives you a graphical dashboard on what exactly is happening. What is the network throughput, what is the disk I/O, what is the memory that you're consuming, what is the CPU that you're consuming, etc., etc. And there are a lot of instance types in the way they spin machines. General purpose instances are T2 and M3, which come with minimum, a normal CPU and a normal memory ranges, which are not really tuned for any compute intensive or graphic intensive computing. And 99% of the cases, what we use in performance testing is the M3 type of instances, which come with anything between 6 GB to 15 GB of RAM and 4 to 12 CPU machines. And then you have another category of instances which are compute optimized instances. They are denoted as C3. We'll see how they look like when we actually go onto the AWS website. These particular instances have more CPU and they are used for compute intensive applications. And let's say you have a mapping solution provider, which we have worked with a couple of months ago. These are geolocation providers who read a lot of flat files and do a lot of math in order to actually map any point and give latitude, longitude information. And we have actually taken their solution to the Amazon cloud, deployed there, and they wanted to have 32 CPUs and a minimum of 64 gigabytes of RAM. If you see the difference between the CPU and the RAM, it's pretty less. You're having a lot of CPU there. But their application is a compute-intensive application. So if you have any requirements for compute-intensive operations, you go and select your C3 instances. And then you have GPU instances, which are for 3D graphics, media, and gaming, which involves a separate graphic cards in addition to your CPUs. And then there are memory optimized instances. These provide large memory for high throughput, for NoSQL databases, big data, etc., etc. And then there are storage optimized instances, which is actually tuned across disk I/O. So let me go to awsamazon.com and sign into my account and see how you actually spin up an instance, and how do you actually map load generators, what are the options available. And these are the different services that your Amazon offers. What we are right now using is an EC2. We are not using any VPC. We are using an elastic compute. And you can go to any location. These are the locations that Amazon offers you instances in. You have North Virginia, Oregon, North California, and Ireland and Frankfurt in Europe region, Singapore, Tokyo, Sydney in Asia Pacific, and Sao Paulo in South America. Right now I'm in North Virginia region, and I have already one running instance to Keybase, Elastic IP, snapshots, etc. Let's say you want, I'll show you how to launch an instance. You can just go to your EC2 dashboard and straight away click on launch an instance. These are the different types of operating systems that are available, different types of configurations that are available. You can select any one configuration. Right now I'm selecting a Windows Server 2012 R2. Once you select it, you select what is the configuration that you want. You have your T2, M3 instances, general purpose instances, and then you have your compute optimized instances, GPU instances, memory optimized. What I'm doing is I'm selecting an M3 medium, which has one CPU, 3.75 gigs of RAM, and then I'm going to configure instances here. How many number of instances that I want? Right now I'm leaving it for 1. And if you have a VPC account with you, you can launch this particular instance directly to VPC, or you can launch to EC2 Classic. When you launch into EC2 Classic, it's an on-demand instance. Availability zone, you can select 1A, 1C, 1D, 1E. These are different availability zones within the location, US East location. This is done in order to prevent a single point failure. And then this is pretty important. When you actually configure an instance, you should specify your shutdown behavior, whether to stop or terminate. Don't select a terminate here. It terminates the instance, and select this protect against accidental termination. If you want to enable CloudWatch monitoring, it charges you more. Then go and add your storage. For a performance testing, 30 gigabytes of hard disk storage is right now enough. You can select your provisioned IOPS or general purpose IOPS or magnetic SSD. I'm leaving it general purpose IOPS. And then you can tag an instance. You can give a name value pair here. And then security groups, what it means is you can create your own security group in order to allow some inbound, outbound rules. For example, the one that I selected here has a port range of 0 to all ports, allow all TCP/IP traffic here, all ports allow all UDP traffic here. So you can have as many security groups, and or you can create your own new security group and map that to your instance, or use an existing security group that you want to use here, which is very strict security group or pretty open security group that you want to use. And once you click review and launch, you will have your instances coming up under instances tab. You go to your instances. These are all the instances that we are actually operating with. By default, it will be in a stop state. You can just select that, and you click start, and your instance starts up. Right now, I'm going to the controller. Just a moment. This is your public DNS. You can just take this, go to an MSTSC, turn it as administrator, say connect. Just give me 1 minute there. While I do this, I'll just show you what are the generators that I have. I have one load generator in Asia Pacific Singapore location. I can just switch to Singapore location. I similarly have an LR agent here in its own availability zone and its own security group settings. I also have a load generator in North California region, where my controller is sitting in North Virginia region. Here it is. You can just map your load generators, take those public elastic IPs and map them here, or take the public DNS without any elastic IPs, and you can say disconnect, or you don't want to use this particular load generator, or connect if you want to use this particular load generator. This particular load runner installation was already done, and right now this is communicating with different load generators in different locations. Excuse me. Let's say start scenario. Now with load runner, you can have this particular load generators situated anywhere. For example, I have one situated in Singapore, the other situated in North California, with controller in North Virginia. But with JMeter, what happens is, if they are not under the same subnet, you'll have to run multiple masters in multiple locations, and then have all the logs centralized and do your own analysis. Excuse me. For which we have developed our own solution. Just a moment. All right. So you have seen how to spin the load generators on the cloud and how to set up a performance lab. The session is open for questions now. I'm keeping a tab on the time that we are left with. Please shoot out the questions, whatever you have.
Thanks, Grant. I think that's pretty insightful. We open for questions. I'm very sure that this was a very strong session on the deep dive about performance testing on the cloud.
So I request all our participants to stay connected with us. I think Kranti is encounters a problem. He will be back shortly. So,
No, yeah, Kranti is right here. We are waiting for questions that we can take.
okay, are we?
Just pause for questions. Yes, Kranti is here.
Okay. So I'm very thankful for having this presentation. Right. So I request Kranti to start taking up the question. Before answering the questions, I request them to please read out question loudly.
Yeah, we will do that stuff. Yeah.
Okay. Visit to the question panel. There you can see different questions.
Yeah, we see this one. How do we handle distributed testing issue with JMeter while working in different subnet masks? I think that's an interesting question. Would you like to?
Yeah. Well, the solution is you'll have to get this particular JTL file to be written into a central database rather than writing it to a local JMeter master. For which we have developed our own IP solution. The simple answer is you can have different masters in different subnets and have the information written to a central database and aggregate the reports from. There is a question which says, how much have you paid with Amazon? Well, that depends on the relationship that you have, and we cannot actually discuss financials here or tell what is the price that we have paid to Amazon. It depends on the relationship that you have with Amazon. Pretty much 90% of the time their prices are standard, but if you are a gold partner or if you have good relationship with them, you're bound to get your discounts. There is another question, which cloud provider gives the trial license to cloud and which provider is easy to work with for a layman? Well, if I have to take a layman's approach, in my experience, I'm not taking sides here, so don't hold me responsible for this. In my experience, I found Sovasta to be pretty useful when it comes to a layman usage. But most of the time when you go to a near-test cloud or a BlazeMeter cloud, BlazeMeter will use your JMeter scripts and StormRunner will use your LoadRunner scripts. As far as trial license is considered, BlazeMeter does have this particular trial license offer. You may want to go and check it out. With other options, probably we'll update this particular answer on the webinar page where you can come back and look into.
So Kranti, till now we have got 3 questions and you have answered all 3 questions. So we are waiting for some more questions. I request all our participants, if they have any query related to the topic, please share with us. So we have got another question.
Okay, there is a question on what is the best approach for banking related projects as those include monetary transactions. Well, I like to answer this in 2 ways. First of all, any banking related websites or banking related solutions that needs to be performance tested, most often they get performance tested after data obfuscation. Data obfuscation, I mean, you generally don't test it with real data. You tinker the real data and then test it. And number 2, for high transaction load testing, you'll need to and in terms of monetary, financial, social secure data that you don't want to expose to outside world, you need to get your own virtual private cloud, but make sure the bandwidth of your virtual private cloud is enough to hold up all your load testing needs. For example, if you're going to test it with 10,000 users, which is going to demand at least 50 Mbps throughout 2 hours, and if your virtual private network has only a bandwidth of 10 Mbps, you end up testing the bandwidth and not the application. So you need to plan it out. There is another question. Please provide a link to Gallup Cloud Services. You can You can visit gallup.net, or you can just mail us at contact@gallup.net. Any specific website for cloud testing is another question. I really didn't understand the entire details of this question, but what I understand from the question is any specific website for cloud testing. Are you asking? There is no clarity in this question. If you can expand this question on the Gallup webinar link, we can update the answer there.
So Kranti, do you want to wait for some more time to take up the questions?
No, I think we are good. Having said that, I must say some of these questions have been really insightful. We are open for taking more questions, and people can write back to us at contact@gallup.net. And I think these initiatives will keep going forward with Gallup. I'm very sure this was a useful session for everyone.
Right. So I request all our participants, if they have any question or we are not able to answer their query, they can visit to gallup.net or they can visit our website techgeek.com. They can post their question there, and I request Mr. Kranti visit after some time. And if you found any question on our website, on your website, please answer them. So meanwhile, we have got few more questions. Do you want to take it up, or we want?
Okay, any more questions? Two more questions. Can we, okay, there is another question here. Can we do cloud testing for mobile application? Well, good question, but what type of mobile application is it? So my answer is, if you're actually testing a mobile website, yes, or if you're actually testing a mobile native application, but it still uses some sort of web services and you want to know the latency, yes. But if it's only mobile specific application, there is no need to go to the cloud. Okay, my application is on SAP server, so can we do performance testing on it through cloud? More explanation. Sales order application for geographical reasons where thousands of users can hit the server. Yes, you can absolutely do it as long as you allow your load generators to communicate with your server under test. All right, there are no more questions.
Right, Kranti. So I think we are done with. Right, please go ahead.
Yeah, I'd like to thank everyone. I would like to thank the attendees. I would like to thank everyone who has taken time to attend this session. Hope this session is helpful. If you have any queries, please write to us. Please update anything that you want to update on the Gallup webinar page.
Thanks, Kranti, for taking so many questions and conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Thank you, Kranti. Thank you, Subhendu. Thank you, Saira.
Thank you.
Yeah.
Thank you.